Before we begin, take a gentle moment to like this video, subscribe to the channel, and turn on notifications so you never miss another peaceful journey through the universe. If this video helps you relax, let us know in the comments. Now, settle in, get comfortable, and allow the quiet vastness of the Milky Way to guide you toward restful sleep. Tonight, we begin a calm and unhurried exploration of our home galaxy, the Milky Way. A slow drift through space filled with soft facts, gentle discoveries, and quiet cosmic wonders. Fact number 1. The Milky Way is the galaxy that contains our solar system. Fact number 2. It is a barred spiral galaxy, meaning it has a central bar-shaped structure made of stars. Fact number 3. The Milky Way stretches across approximately 100,000 light-years in diameter. Fact number 4. A light year is the distance light travels in 1 year, which is about 5.88 trillion miles. Fact number 5. The Milky Way is estimated to be around 13.6 billion years old. Fact number 6. It contains between 100 billion and 400 billion stars. Fact number 7. Our Sun is just one ordinary star among those billions. Fact number 8. The Milky Way appears as a hazy band of light in the night sky when viewed from Earth. Fact number 9. The name Milky Way comes from its milky, glowing appearance. Fact number 10. In Latin, the Milky Way is called Via Lactea, meaning road of milk. Fact number 11. Ancient Greek mythology described the Milky Way as milk spilled by the goddess Hera. Fact number 12. Many cultures around the world have their own stories about the Milky Way. Fact number 13. The Milky Way has several spiral arms extending outward from its center. Fact number 14. Our solar system is located in a minor spiral arm called the Orion Arm. Fact number 15. The Orion Arm is about 3,500 light-years wide. Fact number 16. We are located roughly 27,000 light-years from the center of the galaxy. Fact number 17. The center of the Milky Way lies in the direction of the constellation Sagittarius. Fact number 18. At the center of the Milky Way is a supermassive black hole. Fact number 19. This black hole is named Sagittarius A star. Fact number 20. Sagittarius A star has a mass about 4 million times greater than our Sun. Fact number 21. Despite its enormous mass, Sagittarius A star occupies a relatively small region of space. Fact number 22. The Milky Way rotates slowly over time. Fact number 23. Our solar system takes about 225 to 250 million years to complete one orbit around the galaxy. Fact number 24. This long journey is sometimes called a cosmic year. Fact number 25. Since its formation, the Sun has orbited the Milky Way around 20 times. Fact number 26. The Milky Way is part of a group of galaxies called the Local Group. Fact number 27. The Local Group contains more than 50 galaxies. Fact number 28. The largest galaxy in the Local Group is the Andromeda Galaxy. Fact number 29. The Milky Way and Andromeda are slowly moving toward each other. Fact number 30. In about 4 to 5 billion years, they are expected to merge. Fact number 31. The Milky Way contains vast clouds of gas and dust. Fact number 32. These clouds are called nebulae. Fact number 33. Nebulae are often regions where new stars are born. Fact number 34. Star formation occurs when gravity pulls gas and dust together. Fact number 35. The Milky Way forms several new stars each year. Fact number 36. Some regions of the galaxy are more active in star formation than others. Fact number 37. The galactic disk contains most of the Milky Way's stars. Fact number 38. The disk is thin compared to the galaxy's overall diameter. Fact number 39. Surrounding the disk is a spherical region called the galactic halo. Fact number 40. The halo contains older stars and globular clusters. Fact number 41. Globular clusters are tightly packed groups of very old stars. Fact number 42. Some globular clusters in the Milky Way are nearly as old as the galaxy itself. Fact number 43. The Milky Way contains over 150 known globular clusters. Fact number 44. The galaxy also contains open star clusters. Fact number 45. Open clusters are younger and less tightly bound than globular clusters. Fact number 46. The Milky Way is constantly moving through space. Fact number 47. It is traveling at about 1.3 million miles per hour relative to the cosmic microwave background. Fact number 48. Dark matter makes up a significant portion of the Milky Way's mass. Fact number 49. Dark matter does not emit light, making it invisible to telescopes. Fact number 50. Scientists detect dark matter through its gravitational effects. Fact number 51. The visible stars represent only a fraction of the galaxy's total mass. Fact number 52. The Milky Way's central bulge is densely packed with stars. Fact number 53. The bulge contains many older red stars. Fact number 54. The galaxy's spiral arms contain many bright, young blue stars. Fact number 55. Blue stars are hotter than red stars. Fact number 56. Some stars in the Milky Way are part of binary systems. Fact number 57. A binary system contains two stars orbiting each other. Fact number 58. There are also triple star systems in the galaxy. Fact number 59. Some stars host planetary systems, like our own. Fact number 60. Thousands of exoplanets have been discovered within the Milky Way. Fact number 61. Many of these exoplanets orbit stars similar to our Sun. Fact number 62. Some exoplanets are located in habitable zones. Fact number 63. A habitable zone is the region around a star where liquid water could exist. Fact number 64. The Milky Way contains vast regions of interstellar space. Fact number 65. Interstellar space is not completely empty. Fact number 66. It contains thin gas, dust, and cosmic rays. Fact number 67. Cosmic rays are high-energy particles traveling through space. Fact number 68. The Milky Way emits radio waves. Fact number 69. It also emits infrared, visible, ultraviolet, and X-ray radiation. Fact number 70. Astronomers study the Milky Way using many types of telescopes. Fact number 71. Radio telescopes can see through dense clouds of dust. Fact number 72. Infrared telescopes help reveal hidden star-forming regions. Fact number 73. The Milky Way has a slightly warped shape. Fact number 74. This warp may be caused by gravitational interactions with nearby galaxies. Fact number 75. The Milky Way has several satellite galaxies. Fact number 76. The Large Magellanic Cloud is one of them. Fact number 77. The Small Magellanic Cloud is another nearby satellite galaxy. Fact number 78. These satellite galaxies orbit the Milky Way. Fact number 79. Over time, the Milky Way can absorb smaller galaxies. Fact number 80. Evidence of past galactic mergers can be found in stellar streams. Fact number 81. Stellar streams are elongated trails of stars. Fact number 82. They are remnants of smaller galaxies pulled apart by gravity. Fact number 83. The Milky Way's disk is about 1,000 light-years thick. Fact number 84. The central bulge spans about 10,000 light-years. Fact number 85. The galaxy contains many supernova remnants. Fact number 86. A supernova occurs when a massive star explodes. Fact number 87. Supernovae spread heavy elements into space. Fact number 88. Elements like iron and calcium were formed in ancient stars. Fact number 89. The atoms in your body were once part of stars. Fact number 90. The Milky Way is only one of trillions of galaxies in the observable universe. Fact number 91. Yet, it is the only galaxy we call home. Fact number 92. On a clear, dark night, the Milky Way can be seen stretching from horizon to horizon. Fact number 93. Light pollution makes it harder to see the Milky Way. Fact number 94. Ancient navigators used the Milky Way as a guide. Fact number 95. The galactic center is brightest in infrared light. Fact number 96. The Milky Way's stars orbit the center at different speeds. Fact number 97. Our sun travels at about 514,000 miles per hour around the galaxy. Fact number 98. Even at that speed, the journey around the galaxy takes hundreds of millions of years. Fact number 99. The Milky Way is gently evolving over cosmic time. Fact number 100. And right now, as you rest, you are quietly traveling through it. Take a slow breath in. Imagine the vast spiral arms stretching across darkness. Feel the calm of billions of distant stars shining softly in the night. This is only the beginning of our peaceful journey through 500 relaxing facts about the Milky Way. When you are ready, we will continue to drift deeper into our galaxy. Let the quiet continue. There is no rush here, no bright transitions, no sudden sounds, only the steady rhythm of distant stars and your own calm breathing. In this extended portion of our journey, we drift deeper, not to count new facts, but to gently expand on the wonder of the 500 we have already explored. Think of this as floating between the stars themselves, moving slowly through meaning and memory. Take a soft breath in and out. The Milky Way is not something distant from you. It is the environment in which you exist. Every direction you look in the night sky, every faint star you see, is part of this same galaxy. When you look upward, you are looking outward across a rotating disk of hundreds of billions of suns. Our galaxy is shaped like a spiral, but it is not a rigid spiral. It is fluid, dynamic, slowly evolving. The spiral arms are not fixed structures. They are regions where gravity has gently gathered material into denser waves. Stars drift through them. Gas collects, new suns ignite, and then the stars continue onward in their long, quiet orbits. The sun itself is moving. Right now, it is traveling at roughly 514,000 miles per hour around the center of the Milky Way. Yet, you do not feel this motion. Earth moves with it. The solar system moves together, gracefully, like a quiet caravan orbiting the galactic center. One complete orbit takes about 230 million years. When the dinosaurs roamed Earth, the sun was in a different part of the galaxy. When the first mammals appeared, we were somewhere else along the spiral arm. When humans first looked up at the night sky, the solar system had shifted again, only slightly, in its immense orbit. And still, the motion continues. The center of the Milky Way is 27,000 light-years away. At its heart lies Sagittarius A star, a supermassive black hole containing the mass of 4 million suns. It does not pull us inward. It does not threaten us. It simply anchors the galaxy with gravity. Around it, stars orbit in elegant arcs. Some complete a full orbit in mere decades. Their paths curve through warped space-time, confirming the predictions of Einstein's general relativity. Gravity bends light. Gravity shapes motion. Gravity holds the Milky Way together. But gravity is not alone. Dark matter, invisible and silent, surrounds the galaxy in a vast halo. We cannot see it directly. It emits no light. But we know it is there because of how stars move. Without dark matter, the galaxy would spin apart. With it, everything remains here-bound. The halo extends far beyond the visible disk, hundreds of thousands of light-years outward into space. Sparse stars inhabit this region. Ancient globular clusters drift there, tightly packed spheres of some of the oldest stars in existence. Many of those stars formed more than 13 billion years ago. They shine softly still. Within the disk, new stars are forming even now. Giant molecular clouds collapse slowly under their own gravity. Hydrogen atoms fuse. Light is born. A star ignites. Some stars will live for billions of years. Others, massive blue giants, will burn fast and die young in brilliant supernova explosions. When they explode, they scatter heavy elements across space. Carbon, oxygen, iron, elements that will one day form planets, and perhaps life. Every atom in your body was forged in a star within this galaxy. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it began inside ancient stellar cores, long before Earth existed. The Milky Way is not separate from you. You are made of it. The galaxy contains over 150 known globular clusters. It contains open star clusters, looser, younger groupings of stars born from the same cloud. It contains nebulae, glowing clouds of gas illuminated by newborn suns. The Orion Nebula is one such region, visible even to the naked eye under dark skies. It is about 1,344 light-years away, close in galactic terms. Elsewhere, dense dust clouds create dark lanes across the bright band of the Milky Way. The Great Rift splits the glowing river of stars into shadowed sections. But even those dark patches are not empty. They are full of material waiting to become something new. The Milky Way is recycling itself constantly. Stars form, stars shine, stars fade, stars return their material to space, and the cycle continues. In about 4 to 5 billion years, the Milky Way will merge with the Andromeda Galaxy. But even that grand event will unfold slowly, over billions of years. Stars are so far apart that direct collisions are unlikely. Instead, the galaxies will pass through each other, reshaping into a new structure, perhaps an elliptical galaxy, sometimes nicknamed Milkomeda. But that is far in the future. For now, the galaxy is calm, stable, rotating slowly. Above you, wherever you are, the Milky Way stretches from horizon to horizon on a clear, dark night. A soft band of light composed of billions of distant suns, too faint to distinguish individually. If you were to leave the galaxy and look back, you would see a luminous spiral about 100,000 light years across, a central bar, curving arms, a faint outer halo. You would see our home as one among trillions of galaxies in the observable universe. Yet, it would still be unique to us, because this is where our story unfolds. The Milky Way contains history written in starlight, ancient mergers, stellar streams, moving groups of stars sharing common origins. Modern spacecraft, like Gaia, have mapped over 1 billion stars with extraordinary precision. Their distances, their motions, their subtle shifts across the sky. Through that data, we see the galaxy not as a flat image, but as a living, three-dimensional structure. A city of stars, some close, some unimaginably far. And right now, as you rest, you are moving with it. The Earth rotates. The Earth orbits the Sun. The Sun orbits the galactic center. The galaxy moves within the local group. The local group drifts through the expanding universe. All of this motion. And yet, you feel still. That is the quiet beauty of cosmic scale. Take another slow breath. Imagine floating above the spiral arms. Blue star clusters outlining their curves. Red nebulae glowing softly. Dark lanes threading through luminous clouds. Everything moving gently. Everything held together by gravity and time. There is no need to understand it all at once. Just let the scale of it relax you. The Milky Way has existed for over 13 billion years. It will continue for billions more. And for this brief moment, you are here, a conscious part of it, resting beneath its quiet glow. Let your thoughts drift like distant stars. Let your breathing remain steady. The galaxy will continue its slow rotation, whether you are awake or asleep. So now, allow yourself to drift. Let your breathing become even slower now. Imagine yourself resting on a quiet hillside beneath a perfectly dark sky. Above you, the Milky Way stretches in a soft river of light. We continue gently, beginning with fact number 401. Fact number 401. The Milky Way has been observed by humans for thousands of years. Fact number 402. Ancient civilizations studied its movement across the sky. Fact number 403. Early astronomers did not know it was made of stars. Fact number 404. In 1610, Galileo Galilei used a telescope to observe it more closely. Fact number 405. Galileo discovered that the Milky Way is composed of countless faint stars. Fact number 406. This discovery changed humanity's understanding of the cosmos. Fact number 407. Later, astronomers mapped star positions carefully. Fact number 408. William Herschel attempted one of the first maps of the galaxy. Fact number 409. Herschel used star counts to estimate its shape. Fact number 410. His model placed the Sun near the center, which we now know is not correct. Fact number 411. In the early 20th century, Harlow Shapley studied globular clusters. Fact number 412. Shapley discovered that these clusters were centered elsewhere. Fact number 413. His work revealed that the galactic center lies far from the Sun. Fact number 414. Edwin Hubble later showed that other galaxies exist beyond the Milky Way. Fact number 415. This discovery expanded the known universe dramatically. Fact number 416. The Milky Way is just one galaxy among trillions. Fact number 417. Radio astronomy revolutionized our understanding of its structure. Fact number 418. radio waves can penetrate interstellar dust. Fact number 419. Hydrogen gas emits radio waves at a specific wavelength. Fact number 420. This wavelength is known as the 21 centimeter line. Fact number 421. Mapping the 21 centimeter line revealed the galaxy's spiral arms. Fact number 422. Infrared astronomy further improved our view of the center. Fact number 423. Infrared light passes through dust clouds more easily than visible light. Fact number 424. Space telescopes avoid atmospheric interference. Fact number 425. The Hubble Space Telescope has studied many Milky Way objects. Fact number 426. The Spitzer Space Telescope mapped infrared emissions. Fact number 427. The Chandra X-ray Observatory studies high-energy regions. Fact number 428. Each wavelength reveals a different aspect of the galaxy. Fact number 429. The Milky Way's mass influences the motion of nearby galaxies. Fact number 430. Its gravitational field shapes the local group. Fact number 431. The Milky Way and Andromeda are the two largest local group galaxies. Fact number 432. Smaller galaxies orbit them both. Fact number 433. The local group spans about 10 million light-years. Fact number 434. The Milky Way's disk rotates clockwise when viewed from above its north pole. Fact number 435. Stars closer to the center orbit faster in terms of angular motion. Fact number 436. The Sun's galactic orbit is nearly circular. Fact number 437. It also oscillates slightly above and below the galactic plane. Fact number 438. This oscillation may influence long-term climate patterns on Earth. Fact number 439. The Milky Way contains complex organic molecules. Fact number 440. These molecules form in cold interstellar clouds. Fact number 441. Some molecules contain carbon chains. Fact number 442. Organic chemistry occurs naturally in space. Fact number 443. Meteorites sometimes contain interstellar grains. Fact number 444. These grains predate the formation of the solar system. Fact number 445. The Milky Way's dust grains are extremely small. Fact number 446. Many are smaller than a micrometer. Fact number 447. Dust plays a critical role in cooling gas clouds. Fact number 448. Cooling allows gravity to collapse clouds into stars. Fact number 449. The Milky Way's future depends on gravity and dark energy. Fact number 450. Over billions of years, galactic structures evolve. Fact number 451. The Sun will eventually exhaust its hydrogen fuel. Fact number 452. In about 5 billion years, it will expand into a red giant. Fact number 453. By then, the Milky Way and Andromeda will be close to merging. Fact number 454. The night sky of future Earth would appear dramatically different. Fact number 455. The galactic merger will not destroy most planetary systems. Fact number 456. Stars are separated by enormous distances. Fact number 457. The Milky Way may one day become part of a larger elliptical galaxy. Fact number 458. Astronomers sometimes call this future galaxy Milky Way. Fact number 4, 159. The merged galaxy will contain even more stars. Fact number 460. Its structure will be smoother and less spiral-shaped. Fact number 461. Over time, star formation may gradually slow. Fact number 462. Gas supplies will diminish. Fact number 463. The galaxy will age quietly. Fact number 464. White dwarfs will cool into black dwarfs over unimaginable time spans. Fact number 465. Black dwarfs have not yet formed in the universe. Fact number 466. The Milky Way will continue orbiting within its cosmic environment. Fact number 467. Gravity binds it to the local group. Fact number 468. The local group itself moves through space. Fact number 469. All galaxies participate in cosmic expansion. Fact number 470. Space itself is expanding between galaxy groups. Fact number 471. The Milky Way remains gravitationally bound internally. Fact number 472. Its stars continue their silent orbits. Fact number 473. Every star you see in the night sky belongs to the Milky Way. Fact number 474. Some stars are much older than Earth. Fact number 475. Others are still forming today. Fact number 476. The galaxy contains regions of both birth and decay. Fact number 477. Stellar life cycles shape its evolution. Fact number 478. The Milky Way glows softly in long exposure images. Fact number 479. From space, it would appear as a luminous spiral. Fact number 480. Its spiral arms are outlined by clusters of bright stars. Fact number 481. Dark lanes trace paths of dense dust. Fact number 482. The central bulge shines with concentrated starlight. Fact number 483. Beyond the visible disk lies an extended halo. Fact number 484. That halo is largely invisible. Fact number 485. Dark matter holds much of the galaxy together. Fact number 486. Without gravity, the galaxy would not exist in its present form. Fact number 487. Gravity shapes stars, planets, and galaxies alike. Fact number 488. The Milky Way is both ancient and dynamic. Fact number 489. It changes slowly across cosmic time. Fact number 490. Yet on human timescales, it appears constant and calm. Fact number 491. When you look at the Milky Way, you are looking into deep time. Fact number 492. Some of its light began traveling before human civilization existed. Fact number 493. That light crosses thousands of light years to reach you. Fact number 494. Each photon carries a story from distant space. Fact number 495. The Milky Way connects us to the wider universe. Fact number 496. Our solar system is a tiny part of its vast structure. Fact number 497. Yet it is our home. Fact number 498. Every atom in your body formed within this galaxy. Fact number 499. You are, in a very real sense, made of stardust. Fact number 500. And as you rest beneath the quiet night sky, the Milky Way continues its slow, graceful dance around you. Take one final deep gentle breath. If this peaceful journey through 500 relaxing facts about the Milky Way helped you unwind, remember to like the video, subscribe to the channel, and share it with someone who loves calm cosmic stories. Leave a comment letting us know where you're watching from and what topic you'd like to drift through next. Now, allow the galaxy to fade softly into the background of your thoughts and drift peacefully into sleep. Let your breathing grow softer again. Inhale slowly, as though drawing in starlight. Exhale gently, as though releasing the day. We continue drifting, not toward anything urgent, not toward any conclusion, simply deeper into the calm presence of our galaxy. Imagine yourself floating just above the galactic plane. Below you, the Milky Way stretches outward in luminous arcs. From this vantage point, the spiral arms look like gentle brushstrokes of light across a velvet canvas. The Orion Arm, our home, is only a small spur between larger spiral arms. It is not the brightest, it is not the densest. It is simply one quiet neighborhood among many. If you could travel outward from the sun at the speed of light, it would take 27,000 years to reach the galactic center. If you traveled in the opposite direction, it would take tens of thousands of years to reach the outer edge of the disk. Distance in the galaxy is measured not in miles, but in light years. In the time, light itself needs to cross the dark. Light from some stars you see tonight began its journey before recorded human history. Light from others began traveling before humans existed at all. When you look at the Milky Way, you are looking backward in time. The galaxy contains regions so dense with stars that the night sky from within them would never be fully dark. In the central bulge, stars are packed much closer together than in our neighborhood. The sky there would glow continuously. Yet here, in our region of the Orion Arm, the distances between stars are wider. The night sky allows darkness between the points of light. That darkness is not empty. It contains thin gas, mostly hydrogen, drifting at incredibly low densities. On Earth, even the best vacuum chambers contain more particles than some regions of interstellar space. And still, that faint gas matters. Over millions of years, gravity gathers it. Over millions more, it collapses. From something almost nothing, a star can form. The Milky Way is not just a collection of stars. It is also a web of motion. Stars orbit the center at different speeds depending on their distance. Yet, unlike planets in a solar system, the outer stars in our galaxy orbit at nearly the same speed as inner stars. This surprising observation is one of the reasons scientists proposed dark matter. Invisible mass shapes visible motion. The halo of dark matter surrounding the galaxy extends far beyond the visible disk, perhaps 200,000 light-years or more. If you could see dark matter, the Milky Way would appear far larger than it does in photographs. The galaxy also vibrates gently. Studies show that the disk ripples slightly, likely due to past interactions with smaller galaxies. These ripples move slowly, like waves across the surface of a vast cosmic ocean. Nothing in the Milky Way is completely rigid. Everything moves, everything responds to gravity. Within the galaxy, there are regions of silence and regions of brilliance. There are supernova remnants, expanding shells of gas left behind after massive stars exploded. These remnants glow in X-rays and radio waves, marking where stars once lived. There are neutron stars, incredibly dense objects where matter is packed so tightly that protons and electrons have merged into neutrons. Some spin rapidly, emitting beams of radiation like cosmic lighthouses. There are stellar mass black holes, remnants of massive stars whose cores collapsed beyond neutron density. Most of them are quiet, invisible, detectable only by how they affect nearby matter. And then there is Sagittarius A star, steady at the center. 4 million solar masses compressed into a region smaller than our solar system. It anchors the galaxy, yet it is only a tiny fraction of the Milky Way's total mass. The majority of the galaxy's stars lie in the disk, a thin structure compared to its width. The disk is only about 1,000 light years, thick in most places, though the central bulge swells thicker. From the side, the galaxy would look like a glowing pancake with a bright center. From above, it would look like a spiral seashell made of light. Globular clusters orbit in the halo like ancient guardians. These clusters are densely packed spheres containing hundreds of thousands of old stars. They formed early in the galaxy's history. Some of their stars are nearly as old as the universe itself. Open clusters, in contrast, are younger and loosely bound. Over time, gravitational interactions cause them to disperse. Their stars drift apart, blending into the general stellar population of the disk. Even the Milky Way's spiral arms are temporary structures. Over cosmic timescales, their shape may shift. Arms may fade, new ones may emerge. The galaxy you see now is not the same galaxy that existed billions of years ago, and it will not be the same billions of years from now. Yet, change in the Milky Way happens slowly. On human timescales, it feels eternal. If you step outside on a dark night, far from city lights, you may see the Milky Way arching overhead like a pale river of stars. That river is the combined glow of billions of distant suns, each one with its own story, each one moving in its own quiet orbit. The large and small Magellanic Clouds, 2 small satellite galaxies, orbit the Milky Way. From the southern hemisphere, they appear as faint, cloudy patches in the sky. They are gravitationally bound to our galaxy. Over time, they too may merge with it. The Milky Way grows gradually by absorbing smaller companions. Stellar streams trace the paths of past mergers. Long arcs of stars stretched across the halo. These streams are the fossil record of galactic history. The galaxy remembers every interaction, every collision, every slow gravitational embrace. And yet, through all of this, it remains stable enough for life to emerge on at least one small planet, orbiting an ordinary star. Our solar system lies within what scientists sometimes call the galactic habitable zone, a region not too close to the energetic center, not too far into the sparse outskirts. Here, heavy elements are abundant enough to form rocky planets. Radiation levels are moderate, conditions are steady, and so, on Earth, oceans formed, atmospheres developed, life evolved. You are here, a conscious observer within a rotating spiral of stars. The Milky Way does not know you individually, but you are made from its substance. You are part of its ongoing story. Take another slow breath. Imagine drifting outward now, rising above the disk, watching the spiral arms curve gently below you. The galaxy rotates slowly beneath your vantage point. No sound, no rush, just quiet motion through endless space. Let that image soften your thoughts. Let the vastness shrink your worries. The Milky Way has endured for over 13 billion years. It will continue, turning long after this night fades into morning. So rest, float, allow the calm of cosmic scale to carry you. Let your breathing remain slow and steady. There is nowhere else you need to be. The galaxy continues its quiet rotation, and we continue our gentle journey through it. Fact number 101. The Milky Way is shaped like a flattened disk with a bright central bulge. Fact number 102. If you could view it from above, it would resemble a glowing pinwheel. Fact number 103. The spiral arms are not solid structures, but regions of higher star density. Fact number 104. Stars move in and out of spiral arms over time. Fact number 105. The spiral pattern is maintained by density waves moving through the disk. Fact number 106. These density waves compress gas clouds as they pass. Fact number 107. Compressed gas clouds often trigger new star formation. Fact number 108. The spiral arms are named Perseus, Scutum Centaurus, Sagittarius, and Norma. Fact number 109. Our Orion Arm is sometimes called the Orion Spur. Fact number 110. The Sun is located near the inner edge of the Orion Arm. Fact number 111. The Milky Way's disk contains most of its visible light. Fact number 112. The central bulge contains a dense population of stars. Fact number 113. Many stars in the bulge are older than our Sun. Fact number 114. Some bulge stars have lower metallicity than younger stars. Fact number 115. In astronomy, metals refer to elements heavier than hydrogen and helium. Fact number 116. The earliest stars formed mostly from hydrogen and helium. Fact number 117. Heavier elements were formed later through nuclear fusion in stars. Fact number 118. The Milky Way's halo extends far beyond the visible disk. Fact number 119. The halo is nearly spherical in shape. Fact number 120. It contains sparse stars and globular clusters. Fact number 121. The halo is dominated by dark matter. Fact number 122. Dark matter forms an invisible framework around the galaxy. Fact number 123. Without dark matter, the galaxy would rotate differently. Fact number 124. Observations of rotation curves support the presence of dark matter. Fact number 125. The outer stars orbit at similar speeds to inner stars. Fact number 126. This was unexpected before dark matter was proposed. Fact number 127. The Milky Way's rotation curve is relatively flat. Fact number 128. The galaxy's mass is estimated to be over 1 trillion times the mass of the Sun. Fact number 129. Much of that mass is invisible. Fact number 130. The Milky Way's gravitational pull extends far into space. Fact number 131. It influences nearby satellite galaxies. Fact number 132. Some satellite galaxies are slowly being torn apart. Fact number 133. The Sagittarius dwarf galaxy is one example. Fact number 134. It is currently merging with the Milky Way. Fact number 135. Streams of stars from this dwarf galaxy wrap around ours. Fact number 136. These streams help astronomers study the Milky Way's structure. Fact number 137. The Large Magellanic Cloud is about 160,000 light-years away. Fact number 138. The Small Magellanic Cloud is slightly farther. Fact number 139. Both are visible from the southern hemisphere. Fact number 140. They are irregular in shape. Fact number 141. The Milky Way's gravitational forces distort them. Fact number 142. The Milky Way also contains stellar nurseries. Fact number 143. One famous nursery is the Orion Nebula. Fact number 144. The Orion Nebula is visible to the naked eye. Fact number 145. It is located about 1,344 light-years from Earth. Fact number 146. The Orion Nebula contains thousands of young stars. Fact number 147. Some of these stars are only a few million years old. Fact number 148. That is very young on cosmic timescales. Fact number 149. The Milky Way also contains planetary nebulae. Fact number 150. A planetary nebula forms when a sun-like star sheds its outer layers. Fact number 151. These glowing shells expand into space. Fact number 152. The remaining core becomes a white dwarf. Fact number 153. White dwarfs are extremely dense stellar remnants. Fact number 154. A teaspoon of white dwarf material would weigh tons on Earth. Fact number 155. The Milky Way likely contains billions of white dwarfs. Fact number 156. It also contains neutron stars. Fact number 157. Neutron stars form from massive star explosions. Fact number 158. They are incredibly dense. Fact number 159. Some neutron stars are observed as pulsars. Fact number 160. Pulsars emit beams of radiation as they spin. Fact number 161. These beams can sweep past Earth like lighthouse beams. Fact number 162. The Milky Way contains many pulsars. Fact number 163. Some pulsars rotate hundreds of times per second. Fact number 164. These are known as millisecond pulsars. Fact number 165. Black holes also populate the Milky Way. Fact number 166. Stellar mass black holes form from massive stars. Fact number 167. There may be millions of stellar mass black holes in our galaxy. Fact number 168. Most are difficult to detect. Fact number 169. Astronomers often find them through X-ray emissions. Fact number 170. These X-rays occur when matter falls into the black hole. Fact number 171. The Milky Way contains giant molecular clouds. Fact number 172. These clouds are cold and dense. Fact number 173. They are the birthplaces of new stars. Fact number 174. Some molecular clouds span hundreds of light years. Fact number 175. Gravity slowly pulls clumps within them together. Fact number 176. Over time, these clumps collapse into protostars. Fact number 177. Protostars gradually heat up as they contract. Fact number 178. When nuclear fusion begins, a new star is born. Fact number 179. The Milky Way's star formation rate is modest. Fact number 180. It forms roughly 1 to 3 solar masses worth of stars each year. Fact number 181. Some galaxies form stars much faster. Fact number 182. Others have nearly stopped forming new stars. Fact number 183. The Milky Way is considered a relatively typical spiral galaxy. Fact number 184. It is not unusually large or unusually small. Fact number 185. It has a calm star formation rate compared to starburst galaxies. Fact number 186. The galactic center region is more active. Fact number 187. Strong magnetic fields exist near the center. Fact number 188. Clouds of hot gas swirl around Sagittarius A star. Fact number 189. Occasionally, stars pass close to the central black hole. Fact number 190. Their orbits help scientists measure the black hole's mass. Fact number 191. Some stars orbit Sagittarius A star in just a few decades. Fact number 192. These stars move at incredible speeds. Fact number 193. Observing them confirms predictions from general relativity. Fact number 194. The Milky Way contains cosmic dust lanes. Fact number 195. These lanes can block visible light. Fact number 196. Infrared light can pass through much of this dust. Fact number 197. That is why infrared telescopes are so important. Fact number 198. Our understanding of the Milky Way improves every year. Fact number 199. New surveys map billions of stars. Fact number 200. Even now, as you rest, scientists continue learning about our galaxy. Take another slow breath. Imagine drifting between quiet stars, floating gently along a spiral arm. Far from noise, far from hurry. Settle a little deeper now. Let your shoulders soften. Let your jaw relax. Let your breathing fall into a slow and steady rhythm, like the silent rotation of the galaxy itself. We continue drifting, not counting, not rushing, simply observing. Imagine the Milky Way from far above, a vast spiral of light suspended in darkness, its central bar glowing warmly, its arms curving outward like gentle waves frozen in time. Each point of light in that spiral is a sun. Many of those suns have planets. Some of those planets may have oceans. Some may have skies. Perhaps somewhere, on a distant world, orbiting a quiet red dwarf, another being is looking up at their version of the Milky Way, unaware that across tens of thousands of light years, you are doing the same. The Milky Way is around 100,000 light years wide. That means if you traveled at the speed of light, faster than anything with mass can travel, it would still take 100,000 years to cross from one side to the other. And yet, compared to the universe, it is modest. There are galaxies far larger. There are galaxies far smaller. The Milky Way is often described as average, and there is something comforting in that. Our home galaxy is not extreme or violent compared to others. It is not a starburst galaxy forming hundreds of stars each year. It is not a quasar blazing with intense radiation from an actively feeding black hole. It is relatively calm, steady, balanced. Its star formation rate is about 1 to 3 solar masses per year. That is enough to keep it alive and luminous, but not so much that it burns through its resources quickly. In its spiral arms, clouds of hydrogen drift quietly. Some collapse slowly under gravity, forming protostars. These protostars gather material over millions of years. Their cores grow hotter, pressure increases, and eventually fusion begins. Light is born. Every star in the Milky Way began this way. as a cloud, then collapse, then a spark of nuclear fire. Our sun did too. About 4.6 billion years ago, in a quiet corner of the Orion Arm, a cloud collapsed. A star ignited. Around it, a disk of dust formed. From that disk, planets emerged. And on one of those planets, much later, you appeared. The Milky Way contains many kinds of stars. Red dwarfs, small, cool, long-lived, are the most common. They burn slowly and steadily. Some may shine for trillions of years, far longer than the current age of the universe. Blue giants, in contrast, live fast and bright. They are massive and luminous, but they exhaust their fuel quickly, sometimes in only millions of years. When they die, they explode in supernovae. Those explosions ripple through the galaxy, sending shockwaves into surrounding clouds. Those shockwaves compress gas, new stars form, creation follows destruction, quietly, inevitably. In the outer regions of the galaxy, the density of stars decreases. The night sky from a planet, they would look darker. Fewer nearby suns, more emptiness between them. Toward the center, the sky would blaze with starlight, stars packed closer together, the central bulge glowing intensely. Near the very center, conditions become extreme. Gravitational forces increase, stellar winds collide, gas clouds swirl in complex patterns. And at the core, Sagittarius A star, the supermassive black hole waits silently. It does not wander. It does not chase. It simply exists, its gravity shaping the motion of everything around it. Stars orbit it in elongated paths. Some approach closely before swinging away again. Astronomers have tracked these orbits carefully, watching how space itself curves near the black hole. The image captured by the Event Horizon telescope revealed a glowing ring, light bending around darkness, a boundary between what can be seen and what cannot. Even so, the black hole is only a tiny fraction of the galaxy's total size. Most of the Milky Way is wide open space. The distance between stars is enormous. If the sun were the size of a coin, the nearest star would be hundreds of kilometers away at that scale. Space is vast, and yet, despite the distances, gravity binds the galaxy together. Dark matter forms a massive halo around the visible structure. It outweighs the ordinary matter, the stars, the gas, the dust, by a significant margin. We cannot see dark matter directly, but without it, the stars in the outer disk would drift away. The galaxy would not rotate the way it does. The Milky Way also hums softly in radio frequencies. Hydrogen atoms emit a faint signal at 21 centimeters. Radio telescopes map this emission to trace the spiral arms. Invisible waves reveal hidden structure. Infrared telescopes peer through dust clouds to observe the central regions. X-ray observatories detect high-energy events, neutron stars, black holes, supernova remnants. Each wavelength tells a different story. Together, they form a layered portrait of our home galaxy. The Milky Way has absorbed smaller galaxies in the past. Stellar streams arc through the halo, faint trails of stars pulled from dwarf galaxies long ago. These streams wrap around the galaxy like delicate ribbons marking ancient mergers. The galaxy is not static. It grows, it evolves, it remembers. In about 4 billion years, Andromeda will draw closer. The two spiral galaxies will begin a slow gravitational dance. Their shapes will stretch and distort. Over time, they will merge into one larger galaxy. But even during that event, stars will mostly pass by each other harmlessly, separated by immense distances. the night sky of that distant future would look breathtaking. Bright arcs of stars, distorted spiral arms filling the heavens. But that future is far away. For now, the Milky Way remains as it has for millions of years, turning slowly, forming stars, recycling matter. You are moving with it. Right now, even as you lie still, the Earth rotates beneath you at roughly 1,000 miles per hour at the equator. The Earth orbits the Sun at about 67,000 miles per hour. The Sun orbits the galactic center at over 500,000 miles per hour. And the galaxy itself drifts through the universe. All of this motion, and yet you feel calm. That contrast is soothing. Immense movement, perfect stillness. Let that thought ease your mind. You are part of something vast, ancient, and steady. The Milky Way has existed for over 13 billion years. It will continue long after this night has passed. So allow yourself to release the day. Allow the quiet spiral arms to hold your thoughts. Imagine drifting between distant stars, surrounded by soft starlight and endless dark. There is nothing urgent here. Only time. Only space. Only the slow, graceful turning of our galaxy. Allow your breathing to become slower still. Imagine floating peacefully above the spiral arms, watching starlight shimmer in complete silence. We continue now, gently from fact number 301. Fact number 301. The Milky Way contains vast regions called emission nebulae. Fact number 302. Emission nebulae glow when energized by nearby young stars. Fact number 303. These nebulae often shine in soft shades of red. Fact number 304. The red glow usually comes from excited hydrogen gas. Fact number 305. Hydrogen is the most abundant element in the galaxy. Fact number 306. Reflection nebulae shine by reflecting the light of nearby stars. Fact number 307. Reflection nebulae often appear blue. Fact number 308. Blue light scatters more easily than red light. Fact number 309. Dark nebulae block light from objects behind them. Fact number 310. These dark clouds create dramatic shapes against the starry background. Fact number 311. The Horsehead Nebula is one famous dark nebula. Fact number 312. It lies within the constellation Orion. Fact number 313. The Milky Way contains thousands of catalogued nebulae. Fact number 314. Many nebulae are only visible with telescopes. Fact number 315. Some are visible even with small backyard equipment. Fact number 316. The galaxy's interstellar gas is mostly hydrogen. Fact number 317. Helium is the second most common element. Fact number 318. Trace elements include oxygen, carbon, and nitrogen. Fact number 319. These elements are essential for life as we know it. Fact number 320. The Milky Way constantly recycles stellar material. Fact number 321. When stars die, they return matter to space. Fact number 322. That matter may later form new stars and planets. Fact number 323. This cycle has continued for billions of years. Fact number 324. Our solar system formed from recycled stellar material. Fact number 325. The Milky Way's disk contains spiral density waves. Fact number 326. These waves move more slowly than individual stars. Fact number 327. Stars pass through spiral arms as they orbit. Fact number 328. Spiral arms are regions of active star formation. Fact number 329. Young star clusters often outline the spiral arms. Fact number 330. Massive blue stars illuminate surrounding gas clouds. Fact number 331. Blue stars live shorter lives than smaller stars. Fact number 332. Red dwarf stars are the most common stars in the Milky Way. Fact number 333. Red dwarfs burn fuel slowly and can live trillions of years. Fact number 334. None have yet reached the end of their natural lifespan. Fact number 335. The Milky Way's oldest white dwarfs are cooling slowly. Fact number 336. Over time, white dwarfs fade and darken. Fact number 337. The galaxy contains many brown dwarfs. Fact number 338. Brown dwarfs are sometimes called failed stars. Fact number 339. They are too small to sustain hydrogen fusion. Fact number 340. Brown dwarfs glow faintly in infrared light. Fact number 341. Some brown dwarfs wander alone through space. Fact number 342. Others orbit stars like distant companions. Fact number 343. The Milky Way's center contains dense star clusters. Fact number 344. Some stars near the center move at extreme speeds. Fact number 345. The gravitational pull there is immense. Fact number 346. Radio waves from the galactic center reveal complex structures. Fact number 347. Astronomers map these structures carefully. Fact number 348. The central region contains strong stellar winds. Fact number 349. These winds push gas outward. Fact number 350. The Milky Way's central bar rotates as a single structure. Fact number 351. The bar helps funnel gas toward the center. Fact number 352. This gas can feed star formation near the core. Fact number 353. The central molecular zone is rich in dense gas. Fact number 354. It spans several hundred light years. Fact number 355. Star formation in this region can be intense. Fact number 356. The Milky Way's disk contains star-forming rings. Fact number 357. Some rings circle the galactic center. Fact number 358. These rings are detected in infrared surveys. Fact number 359. Infrared light reveals heat from dust and young stars. Fact number 360. The Milky Way emits a faint radio hiss across the sky. Fact number 361. This radio emission can be detected by sensitive equipment. Fact number 362. Cosmic rays move through the galaxy at near light speed. Fact number 363. Magnetic fields guide their paths. Fact number 364. The Milky Way's magnetic field has both large and small-scale components. Fact number 365. It follows the spiral structure loosely. Fact number 366. Some regions contain stronger magnetic concentrations. Fact number 367. Magnetic activity influences star formation processes. Fact number 368. The Milky Way's outer disk is less dense than the inner disk. Fact number 369. fewer new stars form in the outer regions. Fact number 370. The outer halo contains ancient stellar relics. Fact number 371. Some halo stars travel on elongated orbits. Fact number 372. These orbits differ from the circular disk orbits. Fact number 373. The halo extends hundreds of thousands of light years. Fact number 374. Dark matter dominates this outer region. Fact number 375. The galaxy's gravitational influence reaches far into space. Fact number 376. Satellite galaxies feel its pull. Fact number 377. Some satellites leave faint tidal tails behind. Fact number 378. These tails trace their orbital paths. Fact number 379. Over time, the Milky Way grows through gentle accretion. Fact number 380. Small galaxies gradually merge with it. Fact number 381. Each merger adds stars and dark matter. Fact number 382. The Milky Way's history is written in stellar motion. Fact number 383. Modern space telescopes measure precise star positions. Fact number 384. The Gaia spacecraft has mapped over 1 billion stars. Fact number 385. Gaia measures positions, distances, and motions. Fact number 386. This data reveals the galaxy's three-dimensional structure. Fact number 387. It also uncovers hidden stellar streams. Fact number 388. The Milky Way continues to change, slowly over time. Fact number 389. Billions of years from now, it will look different. Fact number 390. The Sun will not remain in its current orbit forever. Fact number 391. Gravitational interactions can slightly alter stellar paths. Fact number 392. The Milky Way's future includes merging with Andromeda. Fact number 393. This merger will reshape both galaxies. Fact number 394. Their stars are unlikely to collide directly. Fact number 395. Space between stars is vast. Fact number 396. The night sky would look dramatically different during the merger. Fact number 397. New waves of star formation may occur. Fact number 398. Eventually, the merged galaxy may become elliptical. Fact number 399. This transformation will take billions of years. Fact number 400. And long before then, the Milky Way will continue its quiet, graceful spin. Let your thoughts grow softer now. Picture the slow turning of the galaxy, like a luminous wheel suspended in darkness. Before we gently close this journey, if this series has helped you relax, unwind, or drift more peacefully into sleep, take a quiet moment to like the video, subscribe to the channel, and share it with someone who loves calm cosmic explorations. Your support allows more peaceful journeys like this to exist, with no adverts, no interruptions, just quiet discovery. Now, let everything slow. Let the stars dim to a softer glow. We have traveled through 500 facts about the Milky Way. We have drifted through spiral arms, past glowing nebulae, floated near ancient globular clusters, and imagined the slow orbit of our Sun around the galactic center. Now we simply rest within it. Picture the Milky Way one final time from a distance. a vast spiral galaxy, roughly 100,000 light-years across, a bright central bulge, a long luminous bar, curving spiral arms wrapped gently around it, dark dust lanes tracing delicate patterns between regions of light, surrounding all of it, an enormous halo of dark matter, unseen but essential. The galaxy turns slowly. It has been turning for over 13 billion years, and it will continue turning long after this night passes. Inside that spiral, stars are being born at this very moment. Elsewhere, ancient stars are cooling quietly. In some distant molecular cloud, gravity is gathering atoms into a new sun. In another region, a white dwarf is slowly fading. In the halo, globular clusters orbit in vast arcs, their stars older than Earth itself. Near the center, Sagittarius A star anchors everything with silent gravity. Yet here, in the Orion Arm, life continues on a small blue planet. The Sun, one ordinary star among billions, shines steadily. Earth rotates gently beneath you. The solar system orbits the galactic center. The galaxy moves within the local group, and the local group drifts through an expanding universe. All of this motion, all of this scale, and yet your breathing remains slow, calm, even. The Milky Way does not rush. It does not hurry its stars. It does not force its cycles. Everything unfolds gradually over millions, billions of years. Stars form from quiet clouds. They shine for ages. They return their material to space. The cycle continues, and you too are part of that cycle. The atoms in your body were forged in ancient stellar cores, carbon from long-dead stars, oxygen created in massive suns, iron born in supernova explosions. You are made of galactic history. You are stardust, briefly aware, and that awareness is gentle. There is something peaceful about belonging to something so vast. Your day, whatever it held, is small compared to the age of the galaxy. Your worries are light compared to the mass of billions of stars. And yet, your existence matters because you are a conscious fragment of this enormous spiral. If you could see the Milky Way from beyond its halo, you would see it glowing softly in the dark, a luminous island in a vast cosmic ocean, one among trillions, yet the only one that has ever been home. Somewhere within that glowing structure, on a quiet world orbiting an average star, you are resting now. The galaxy continues its slow rotation. The stars continue their silent orbits. Nebulae glow softly. Dark matter holds everything together. Nothing urgent, nothing loud, only steady motion across deep time. Take one final slow breath in. Hold it gently for a moment and release it. Allow the image of the Milky Way to fade into a soft blur of distant light. Let the spiral arms dissolve into darkness. Let the stars become faint points, then softer still, until there is only calm. If you would like more peaceful journeys through space, science, and quiet wonder, remember to like the video, subscribe to the channel, and leave a comment with the next topic you would love to drift through. For now, let the galaxy turn without you. Let sleep come naturally. The Milky Way will still be there in the morning. Let the quiet deepen. Imagine the stars dimming slightly, not disappearing, just softening, like distant lanterns in a calm night breeze. Your breathing is steady now, slow, even. We continue drifting. Picture yourself traveling outward from Earth, past the Moon, past the orbit of Mars, beyond the outer planets, until the Sun becomes just another bright star among many. From that distance, the solar system blends into the greater pattern of the Milky Way. Our Sun is a yellow dwarf star. average in size, average in brightness, ordinary among billions. It sits roughly halfway between the center of the galaxy and its outer edge. Not too close, not too far, in a quiet suburban region of the Orion Arm. If you could map the galaxy in 3 dimensions, you would see stars positioned above and below the galactic plane, forming a thin but layered disk. The sun itself oscillates gently up and down through this plane over tens of millions of years. It rises, it falls, it continues its orbit, all without hurry. The Milky Way's disk contains lanes of dust that appear dark against brighter backgrounds. These dust grains are tiny, often smaller than a micrometer, yet collectively they obscure entire regions of starlight. Within those dust clouds, molecules form, water molecules, carbon-based compounds, even complex organic molecules. Space chemistry unfolds silently. In some molecular clouds, temperatures are so low that atoms move slowly, allowing delicate bonds to form on dust grain surfaces. Eventually, those clouds collapse and stars ignite. Some regions of the Milky Way glow in radio wavelengths. Hydrogen atoms naturally emit radiation at a wavelength of 21 centimeters when the orientation of their electron and proton spins changes. That faint emission has allowed astronomers to map the spiral structure of our galaxy, even in regions hidden by dust. Without radio astronomy, much of the Milky Way's structure would remain unseen. The galaxy also shines in infrared light. Warm dust and newly formed stars emit infrared radiation that passes more easily through obscuring clouds. Infrared surveys reveal bright star-forming complexes near the galactic center. And in X-rays, the Milky Way shows a different face, one of high-energy phenomena. Binary star systems where matter streams onto neutron stars, black holes consuming gas, remnants of ancient supernovae still glowing faintly. Each wavelength is like a layer of reality. Together, they create a fuller portrait. The Milky Way contains an estimated 100 to 400 billion stars. That range exists because counting them precisely is difficult. Some are hidden, some are faint, some lie behind dense dust. And beyond the visible disk, the dark matter halo extends far outward. If you could see the full gravitational footprint of the Milky Way, it would stretch far beyond its luminous spiral. Satellite galaxies orbit within this halo. The Sagittarius dwarf galaxy is one such satellite, currently being stretched and absorbed by our galaxy's gravity. Its stars form long streams that wrap around the Milky Way. These streams are evidence of past mergers, gentle cosmic assimilation over billions of years. The Milky Way has grown not through sudden violence alone, but through gradual gathering, a slow collection of smaller systems, a patient accumulation of stars. In about 4 billion years, the Andromeda galaxy will approach close enough that tidal forces begin reshaping both galaxies. But even then, the process will unfold over immense timescales. From the perspective of a human lifetime, the Milky Way appears unchanged. The same constellations, the same luminous band across the sky, yet in reality, every star is in motion. The constellations slowly distort over thousands of years. Stars drift along their own paths through the galaxy. The night sky of 10,000 years from now will not look exactly like tonight's sky. But the changes are subtle, gradual, gentle. The Milky Way is part of the Local Group, a collection of more than 50 galaxies bound together by gravity. Beyond the Local Group lies the Virgo supercluster, and beyond that, vast cosmic filaments stretching across unimaginable distances. Yet, even among that grandeur, our galaxy remains our immediate home. If you were to leave the Milky Way entirely and look back, you would see a luminous spiral approximately 100,000 light-years across, its arms outlined by blue star clusters and red emission nebulae. The central bar would glow warmly. Dark dust lanes would carve graceful curves through the disk. It would appear serene, self-contained, balanced. Inside that spiral, billions of planetary systems orbit their stars. Thousands of exoplanets have already been discovered, and there may be billions more. Some orbit red dwarfs, some orbit sun-like stars. Some may lie within habitable zones where temperatures allow liquid water to exist. The possibility of life elsewhere in the Milky Way remains open, quiet, unresolved, and that uncertainty itself is peaceful. The galaxy does not rush to reveal all its secrets. It unfolds them slowly through observation and time. Modern missions like the Gaia spacecraft have mapped the positions and motions of more than 1 billion stars. With that data, astronomers can trace stellar orbits backward, reconstructing past mergers and interactions. The Milky Way carries a memory written in motion. Every star's path is a sentence in its long history. And right now, you are moving with those stars. Even lying still, even resting, the Earth rotates beneath you. The solar system travels around the galactic center. The galaxy itself drifts within the local group. And space continues expanding between distant galaxy clusters. All of this movement, and yet you feel calm. Let that thought settle in. The universe is vast. The galaxy is immense, and your place within it is small, but meaningful. You are part of a 13 billion year story, made of ancient elements forged in stellar cores, breathing air shaped by planetary processes within this same spiral. Take another slow breath. Imagine floating upward again, beyond the disk, beyond the halo, until the Milky Way becomes a glowing island of light in a dark cosmic ocean. It turns slowly, gracefully, its spiral arms curving like a luminous whirlpool. And somewhere within one of those arms, a small blue planet circles a modest star. And on that planet, you rest. Let the scale comfort you. Let the silence soothe you. There is no urgency in the Milky Way. Only time, only motion, only steady, patient rotation. Let the stillness return. There is something comforting about imagining the galaxy continuing on, no matter what happened today. The Milky Way does not hurry. It does not worry. It simply rotates, breathes in gas, forms stars, and releases light into the dark. Take a slow breath in and let it go gently. Imagine now that you are drifting along one of the Milky Way's spiral arms, not above it this time, but within it. Around you are clusters of young stars, glowing blue-white. Their light reflects off nearby clouds of gas, illuminating soft red nebulae. These bright, massive stars will not live long. In cosmic terms, their lives are brief, perhaps only a few million years. They burn hot and fast, fusing heavier elements in their cores until fuel runs out. When that happens, gravity wins. The core collapses. A supernova erupts. For a short time, that single exploding star can outshine entire galaxies. But the explosion is not only destruction, it is also creation. Heavy elements are forged in those final moments. Gold, uranium, and other elements that cannot be formed in ordinary stellar fusion. These materials are scattered into space, enriching the interstellar medium. Eventually, that enriched gas becomes part of new stars and new planets, perhaps even future life. The Milky Way is a vast recycling system. Nothing is wasted. Stars form from gas, stars shine, stars return their material to space, and the cycle continues. Drift now toward a quieter region of the galaxy, away from bright star clusters and energetic supernova remnants. In the outer disk, stars are more sparsely distributed. The glow of the galactic center appears fainter here. If you stood on a planet in this region, the Milky Way might appear as a thinner band across the sky. Fewer nearby stars, more darkness between them. Darkness is not emptiness, it is potential. The outer halo of the galaxy extends far beyond the visible disk. Ancient stars orbit here in elongated paths, moving in directions that differ from the stars in the disk. Many of these halo stars are extremely old. They formed when the Milky Way was young, before it fully developed its spiral structure. Some were once part of smaller galaxies that merged with ours long ago. The Milky Way carries evidence of its past in the motions of its stars. Stellar streams arc across the halo, faint trails of stars left behind by dwarf galaxies that were gradually torn apart by gravity. These streams are delicate, like strands of silk stretched across space. If you could see them clearly, they would wrap around the galaxy in sweeping arcs. The Milky Way is not isolated. It interacts constantly with its environment. The large and small Magellanic Clouds orbit nearby. Their gravitational interaction with our galaxy creates tidal distortions, subtle stretches and compressions of gas and stars. Even now, the Milky Way's disk shows signs of gentle warping. It is not perfectly flat. It bends slightly at the edges, like a vinyl record left too long in the sun. These bends may be caused by gravitational pulls from satellite galaxies. Nothing in the galaxy is rigid. Everything responds to gravity. In the central bar of the Milky Way, stars move along elongated orbits. The bar channels gas inward toward the core, where dense molecular clouds gather. Star formation can be intense in these central regions. Massive star clusters form. Winds from those stars blow outward, shaping nearby gas, and all of it orbits around Sagittarius A star. Despite the immense gravity of the central black hole, it is not constantly devouring stars. Most of the time, it is relatively quiet. Occasionally, clouds of gas drift too close and emit flares of X-rays as they are pulled inward. But, for the most part, it remains a silent anchor. If you could listen to the Milky Way, you would not hear explosions or roaring winds in the way we imagine. Space is nearly a vacuum. Sound does not travel there as it does in air. The galaxy would be silent. Only light would move. Only gravity would shape. Now imagine traveling outward beyond the halo. The Milky Way begins to shrink beneath you. Its spiral arms become clearer in outline. Its central bulge glows warmly. The dark matter halo, invisible to your eyes, extends even farther. At this distance, you see the galaxy as a whole, a balanced spiral, graceful, self-contained, and somewhere within it, a small solar system. And within that system, a small blue planet. And on that planet, you. The Milky Way has existed for more than 13 billion years. It has witnessed the formation of countless stars and the extinction of many more. It has merged with smaller galaxies and grown steadily. It has orbited within the local group, and it continues to evolve. In billions of years, the Andromeda Galaxy will approach. The two spirals will begin a slow dance. Their shapes will distort. Their spiral arms will stretch and intertwine. Over time, they may merge into a larger elliptical galaxy. But this process will unfold over billions of years, far beyond any human lifetime. For now, the Milky Way is calm. The Sun continues its steady orbit, taking roughly 230 million years to complete one circuit around the galactic center. We are only about 1/20th of the way through the Sun's current orbit since its formation. So much time stretches ahead. Let that vastness soothe you. Whatever concerns followed you into this moment are small compared to galactic timescales. The Milky Way does not rush. It turns slowly. It forms stars patiently. It recycles matter over billions of years. You are part of that rhythm. Your atoms were born in ancient stars. Your world formed from galactic dust. Your existence is woven into the fabric of this spiral. Take one more slow breath. Imagine floating gently back toward the Orion Arm, toward the familiar neighborhood of our Sun. The galaxy stretches around you in quiet arcs of light. No noise, no urgency, just steady motion through deep time. Let your body grow heavier against the surface beneath you. Let your thoughts drift like distant stars. The Milky Way continues its slow rotation, and we continue counting gently and unhurriedly. Fact number 201. The Milky Way is part of a larger structure called the Virgo supercluster. Fact number 202. The Virgo supercluster contains thousands of galaxies. Fact number 203. Our local group sits near the outer regions of this supercluster. Fact number 204. Even larger cosmic structures exist beyond the Virgo supercluster. Fact number 205. Galaxies are arranged in vast filaments across the universe. Fact number 206. Between these filaments are enormous cosmic voids. Fact number 207. The Milky Way resides within one of these filamentary structures. Fact number 208. Gravity shapes the large-scale structure of the universe. Fact number 209. The Milky Way formed from the collapse of a massive cloud of gas. Fact number 210. This collapse began not long after the Big Bang. Fact number 211. The earliest stars in the Milky Way were massive and short-lived. Fact number 212. These early stars enriched the galaxy with heavier elements. Fact number 213. The Milky Way likely grew by merging with smaller galaxies. Fact number 214. Evidence of these mergers is found in stellar motions. Fact number 215. Some stars move differently from the majority of the disk. Fact number 216. These unusual motions hint at ancient galactic collisions. Fact number 217. One past merger is known as the Gaia Enceladus event. Fact number 218. This merger occurred billions of years ago. Fact number 219. It significantly shaped the Milky Way's structure. Fact number 220. The thick disk of the galaxy may have formed during such mergers. Fact number 221. The thick disk contains older stars than the thin disk. Fact number 222. The thin disk contains younger stars and more gas. Fact number 223. Our Sun resides in the thin disk. Fact number 224. The Sun formed about 4.6 billion years ago. Fact number 225. It formed from a cloud of gas and dust within the Milky Way. Fact number 226. The solar system orbits within the galactic habitable zone. Fact number 227. The galactic habitable zone is a region favorable for life. Fact number 228. It is far enough from the center to avoid intense radiation. Fact number 229. It is close enough to contain heavy elements needed for planets. Fact number 230. The Milky Way may host billions of potentially habitable planets. Fact number 231. The Kepler Space Telescope discovered many exoplanets. Fact number 232. Some of these exoplanets are Earth-sized. Fact number 233. Others are gas giants larger than Jupiter. Fact number 234. Planetary systems in the Milky Way vary widely. Fact number 235. Some stars host tightly packed planetary systems. Fact number 236. Others have planets in wide, distant orbits. Fact number 237. Rogue planets may drift freely in the galaxy. Fact number 238. Rogue planets do not orbit any star. Fact number 239. They may have been ejected from their original systems. Fact number 240. The Milky Way's interstellar medium is dynamic. Fact number 241. Shock waves from supernovae ripple through space. Fact number 242. These shock waves can trigger new star formation. Fact number 243. They also distribute heavy elements across the galaxy. Fact number 244. Magnetic fields thread through the Milky Way. Fact number 245. These magnetic fields influence gas movement. Fact number 246. The galaxy emits a faint glow in gamma rays. Fact number 247. Gamma rays are the highest energy form of light. Fact number 248. Some gamma rays come from pulsars. Fact number 249. Others may come from interactions involving dark matter. Fact number 250. The center of the Milky Way occasionally flares in X-rays. Fact number 251. These flares occur when material falls toward Sagittarius A star. Fact number 252. The Event Horizon Telescope captured an image of this black hole. Fact number 253. The image revealed a glowing ring of light around darkness. Fact number 254. That light comes from superheated gas. Fact number 255. The black hole itself does not emit light. Fact number 256. Its gravity bends light around it. Fact number 257. This bending effect is called gravitational lensing. Fact number 258. Gravitational lensing can magnify distant objects. Fact number 259. The Milky Way itself can act as a gravitational lens. Fact number 260. Astronomers use lensing to detect unseen objects. Fact number 261. The Milky Way contains variable stars. Fact number 262. Variable stars change brightness over time. Fact number 263. Some variables pulsate rhythmically. Fact number 264. Cepheid variables help measure cosmic distances. Fact number 265. They have a predictable relationship between brightness and period. Fact number 266. Observing Cepheids improved our understanding of the galaxy's size. Fact number 267. RR Lyrae stars are another type of variable star. Fact number 268. They are often found in globular clusters. Fact number 269. Studying them reveals the age of stellar populations. Fact number 270. The Milky Way's oldest stars are over 13 billion years old. Fact number 271. These stars formed shortly after the galaxy itself. Fact number 272. Some contain very few heavy elements. Fact number 273. Astronomers search for extremely metal-poor stars. Fact number 274. These stars offer clues about the early universe. Fact number 275. The Milky Way contains stellar associations. Fact number 276. Stellar associations are loose groups of young stars. Fact number 277. They eventually disperse over time. Fact number 278. The galaxy also contains stellar moving groups. Fact number 279. These groups share a common origin. Fact number 280. The Milky Way's disk vibrates slightly. Fact number 281. Passing satellite galaxies may cause these ripples. Fact number 282. The disk is not perfectly flat. Fact number 283. It gently waves like a vast cosmic sheet. Fact number 284. The galaxy's rotation influences its spiral shape. Fact number 285. Inner stars orbit faster than outer stars in absolute speed. Fact number 286. Yet, their orbital periods differ based on distance. Fact number 287. The Sun's orbital path is slightly elliptical. Fact number 288. It also moves up and down through the galactic plane. Fact number 289. This vertical motion takes tens of millions of years. Fact number 290. The Milky Way's brightness varies across the sky. Fact number 291. The brightest region is toward the galactic center. Fact number 292. Dust clouds create dark rifts in the Milky Way band. Fact number 293. One famous dark region is the Great Rift. Fact number 294. The Great Rift divides the bright band into two parts. Fact number 295. It is caused by dense clouds of interstellar dust. Fact number 296. The Milky Way can be photographed with long exposures. Fact number 297. Astrophotographers travel to dark sky locations. Fact number 298. High mountains and deserts offer clear views. Fact number 299. The galactic core is a favorite target for photography. Fact number 300. And somewhere within that glowing core lies the quiet heart of our galaxy. Let your breathing soften again. Imagine the slow arc of the Milky Way stretching overhead, ancient and calm, filled with stories written in starlight. Let your breathing be soft now, slow enough that it almost blends with the silence of space. We continue drifting, not toward an ending, but toward a deeper calm. Imagine yourself once more within the Orion Arm, the quiet spiral spur that holds our solar system. Around you, stars shine at varying distances. Some appear bright and close. Others are faint and far beyond easy measurement. The nearest star to our Sun is Proxima Centauri, about 4.24 light-years away. Even that near distance is immense. If the Sun were reduced to the size of a small marble, Proxima Centauri would still be hundreds of miles away at the same scale. This is how spacious the Milky Way truly is. Despite containing hundreds of billions of stars, most of it is open space. The average distance between stars in our region is several light years, and between those stars lies the interstellar medium: thin gas, scattered dust, invisible magnetic fields. Within this medium, cosmic rays travel at near the speed of light. These high-energy particles are accelerated by supernova explosions and other energetic events. They wander through the galaxy, guided by magnetic fields that thread through the spiral arms. The Milky Way's magnetic field is subtle but influential. It shapes how gas clouds collapse. It influences how cosmic rays travel. It gently interacts with charged particles drifting between the stars. Nothing dramatic, just quiet influence. The galaxy's disk is not uniform. It contains regions of higher density and regions of relative emptiness. Star formation is more common where gas is abundant. Some spiral arms appear brighter because they contain more young, luminous stars. Older stars tend to glow with softer, reddish light. Red dwarfs, the most common stars in the Milky Way, are faint and cool. You cannot see most of them with the naked eye, yet they vastly outnumber brighter stars like our Sun. If you could see every red dwarf clearly, the night sky would appear far more crowded. The Milky Way also contains variable stars, stars that change brightness over time. Some pulse gently, expanding and contracting in rhythmic cycles. Others vary because they are part of binary systems, eclipsing each other as they orbit. These variable stars have helped astronomers measure distances across the galaxy. Cepheid variables, for example, have a precise relationship between their brightness and their pulsation period. By observing that rhythm, scientists can estimate how far away they are. Even the act of measuring distance becomes a quiet conversation between light and time. In the halo, globular clusters orbit like ancient lanterns. Each cluster may contain hundreds of thousands of old stars packed tightly into a spherical shape. These stars formed early in the galaxy's history, when the Milky Way was still assembling itself from smaller structures. Some clusters orbit far above the galactic plane. Some pass through it. Their paths are long and looping, shaped by gravity alone. If you could watch the Milky Way over millions of years, you would see stars weaving intricate patterns around the center, not random, but governed by physics. The Sun's own orbit is slightly elliptical. It moves around the galactic center at roughly 514,000 miles per hour. At the same time, it gently oscillates above and below the galactic plane, completing a vertical cycle every 60 to 70 million years. This means that over geological timescales, our solar system rises and falls through the galaxy like a slow wave. And yet, here on Earth, life continues unaware of these grand motions. The Milky Way's central region is rich in molecular clouds. Some are so dense that they block visible light almost completely. Astronomers rely on infrared and radio observations to peer into these regions. Within them, stars are forming even now, tiny points of light beginning their long journeys. Some will host planetary systems, some will remain alone, some may shine for billions of years. The Milky Way is not perfectly symmetrical. Past interactions with satellite galaxies have left subtle distortions in its shape. The Sagittarius dwarf galaxy continues to merge with ours, leaving behind stellar streams. The large and small Magellanic clouds pull gently on the galaxy's outer disk. These interactions are slow, graceful, unfolding over billions of years. Nothing sudden, nothing rushed. The Milky Way is also part of a larger cosmic flow. The entire local group of galaxies is moving toward a region of higher mass concentration, sometimes referred to as the Great Attractor. At even larger scales, galaxy clusters form filaments across the universe, separated by vast cosmic voids. But within our galaxy, the motions are contained, bound by gravity, balanced. If you imagine zooming out farther and farther, the Milky Way becomes one luminous spiral among many. And yet, no other galaxy feels like home. This is where our sun formed. This is where Earth orbits. This is where every human who has ever lived has existed. The light you see from the Milky Way's band in the night sky is the combined glow of billions of distant stars. Each one is too faint to stand out individually, but together they create a soft river of light. When viewed from dark locations, far from city lights, the Milky Way appears textured, almost cloud-like. Dark lanes weave through bright regions. The galactic center shines brightest. It is a reminder that we are inside something vast. And yet, it does not press down on you. It does not overwhelm. It simply exists. The galaxy does not demand attention. It offers perspective. Your worries, your plans, your questions, they all unfold within a structure that has endured for more than 13 billion years. The Milky Way has seen stars ignite and fade. It has absorbed smaller galaxies. It has formed countless planetary systems. And in one of them, consciousness arose. You are the Milky Way, becoming aware of itself, a small but remarkable part of its ongoing story. Take a slow breath in and let it go. Imagine floating once more above the disk, watching the spiral arms curve outward in luminous arcs. The galaxy turns slowly beneath you. No sound, no urgency, only time, only motion, only the quiet glow of billions of stars.